Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Let's talk about the new stuff inside Jiralib and at the same time try to draw something that makes sense to understand Jiralib better. Now keep in mind I have the solution open and I added this draw.io at the root of the projects folder. So if I come back inside projects folder, you can now see this jiralib.draw.io, and if you install the draw.io application, you can see this file and open it and note everything. I will use different colors for different things, but don't worry, this is just me playing with colors. The more important thing is for you to understand the relationship. Now, we have a class that is called block, okay? And I will call it, I don't know, J block maybe, or J reference, G reference. So G block, that's the more proper thing. And G block will have another class that is block properties being used by itself. So how will I connect these is just add the connection from here to here, and then I will just maybe make sure that these are just smooth stuff like curved and stuff like that, and I will change the color to be yellow. I like yellow. Okay, so when you look at this, it means that G block has either a field as block properties or he is using block properties one way or another, and you need to go back inside the code and take a look at how he is doing it. For example, if we open what Turtivorti is doing and we open the block and we find the industrial block and we open that, we see that that block property is a field that he's using inside constructors. So this is called block properties and not block property, and that's correct. So if you look at something like this, you need to go into gblock class and take note how this block properties is being used. And if you see space here, just remove it in your searching in the IntelliJ IDEA, because this is for readability, and inside the IntelliJ IDEA we will remove those spaces. Now this is a guideline here for you, and I will call this one fields. Any interface will be purple, red, orange, and blue are classes, and fields will be white. Okay, now as we said, the G block is using block properties. If I'll open the block properties and take a look at that, we will see that block properties has a field, and not like that, a field that is called place facing opposite. Now, I will talk about different things as we go forward, but then we have another class here, and this one is block properties, but BE means that block properties that are related to block entities. Okay, we have another field that says has comparator output. Then we have a class that returns a tree function. How would I show it to you is like this. A class that returns a tree function. It is, sorry, a method that is returning a tree function. Let me do it this way. This is a method, okay? So the other class was the block properties BE, okay? So now we have a method that returns a tree function, and this one is, actually it's a method called comparator output. So comparator output returns a tree function. Don't forget that. It's a field, okay? So we have a comparator output as a field. I'm derping here. So comparator output, and I'm not providing the types here, okay? Now the other one is a render type, and again, it's a field. So render type, and we have a field that is using an interface. So let's do it here. The interface is I-shape factory. The other one is a state properties that is a class. So state properties, and then we have a field that is actually a by predicate. We will talk about the use cases, and don't worry, I just want to make the connections in your brain first, and it says can exist at, and finally we have another field that is a map here, and this is called cache directional shapes. Okay, now all of these are working hand in hand with each other to make this block properties. Okay, so that's that. Although I'm not gonna fix the colorings right now, I will do it between the videos because this will be time consuming. Now the interesting thing is that the block itself will have many more fields, but I will stop right here because, as I said, I want to go in a small chunks. This is a very complex system, and I will talk about each chunk. Now cache directional shapes is a map that will bind the directions that we use into a voxel shape. For example, the north will use this voxel shape, the south direction for the facing will use this this voxel shape, and so on and so forth. Can exist is a by predicate, means that it will take a word, it will take a block position, and it will tell you that, hey, if the block position can have this block type or not. And then has comparator output means that, hey, if we want to have a comparator output by this block or not, this is a Boolean. And then if it's true, we will produce a tree function that will generate the comparator output for us. Okay, so it's not complex. The render type is actually a field of render type. It means that if we have a model, if it's invisible or any other enumeration that we have on the render type enum, we can handle it here. The eye shape factory is actually the way to handle the voxel shapes. State properties. Now we will talk about the state properties. This is another class that we will provide ourselves that adds properties to the block state. And finally, we have some properties that are belonging to the block but are related to block entities, like if we are tickable or not. If we are tickable, then please generate a tick on the block entity for us. Or do we have a block entity for this block or not? And this is the thing that we will want to provide it here again. Now here's the question: couldn't we dissect this last one, the block properties, from the whole system? Dissect this one and say that, hey, get the attributes, get the methods outside of this block and put it under the main one? Yes, we could do that. Because, you know, for adding something like this, actually what he's doing is something like the example. Up until this point, he's just calling the methods on the attributes or stuff like that. But when he goes into block entity properties, he's creating a new instance of this block properties BE, and then he's calling methods on that one to be added inside here. So yes, we could eventually drop this class, the properties for the block entity, and add its fields into the block properties and its methods to the block properties. However, I'm not sure about that one, because honestly, you should think about it in this way. He is providing the type of the block entity for these methods. And if I want to have this, then yes, I can dissect it actually to get the type as a field and then call the methods and use the type. And as I said, I don't have this multi-block properties yet. So yeah, I may want to dissect it inside the same class. So this may be gone in the next videos, because I think it makes things more confused compared to what we need to do. We can make things easier for ourselves. So let's take a look at the class itself and that block properties BE class, because this is the one that is being used as a nested one. Let's start with block properties. Now, as I said, the place facing opposite is a Boolean. Now, keep in mind, many of these are just fields that are not functional in this class. Actually, none of them are functional in this class. And we have methods to assign values to these fields. We don't use functions because down the road, when we go into gblock, we will read values from block properties and we will get these values and handle things inside gblock based on these values. That is why the block properties itself is not as functional as you think. For example, we have this has horizontal facing a method and it recalls its own overload, and all it's doing is this: it adds a horizontal facing to the state properties, and that's it. So what is the use case of state properties? Well, as I said, you will get there when we work with the block itself. However, these are the fields, and I already talked about the fields. So we have a Boolean for making sure that the facing is properly handled. Then we have this block properties BE, that is this class. And right now, it's just a field. We may want to dissect it and basically cut these things and add them here because they are related to the block. And then we have the has comparator output, the tree function for the comparator output, the render type, the shape factory to handle the voxel shapes, then the stat properties that we will look into. It's another class, don't forget. Then we have can exist at. Now this one is interesting. It's a by predicate that says if we can exist in this position in this world, by default it's true, okay? And this can exist, if I want to find it, has other use cases, and this is it, can exist at. So if we want to make sure that we have log that can't exist in a world at some position or in general, for example, the block shouldn't exist in the dimension of nether, we can add the predicate here. So we can say, hey, if the word dot dimension equals nether, then the predicate is false, otherwise it's true. Or I don't know, maybe you want the position to be limited. For example, you may not want to have a block under the sea level, and if we take the sea level as 65, then you can just add a predicate that compares the position and the y value of the position, and if the y value is below 65, then it will not be placed. If it's above the 65 or equal to 65, then it can be placed. Or for example, if you want the block to be only placed when the surrounding is water, so you will have a block pose inside the board, and you can get the blocks around it and check if those needed blocks are water, and if they are not, then the predicate will return false. So this is the use cases of something like this. Okay, some examples. However, here's what you are doing. By default, you are saying that yes, we can place the block at any position in any word. And finally, as I said, we have a map of directions. This is the vanilla direction for the voxel shapes. Now, the use case for this is when your block has complex voxel shapes and you want to rotate them based on the facing. Okay, after these properties, now we have some methods to handle those properties. For example, has horizontal facing. If we are not providing a boolean, means that yes, we want to have the horizontal facing, so we call ourselves with a true. This guy is the overload for this and says if we have the horizontal facing, please add horizontal facing to our state properties class, and then at the end we return ourselves, and this return, this is happening at the end of almost every one of these methods, because we want to be able to chain the commands as we see inside the use case. So he makes the properties, he calls one method and chains the command one after another, because each time he is returning the same instance and he can add more commands on top of that. Then we have a default direction, and this means that we are not using the horizontal facing, but we are putting the facing to be a default direction. Then we have access properties. Now this one calls the other overload with the true, and this overload says that hey, if you have access properties, please go on state properties and add access. As I said, we have to jump back and forth between few different classes. I'm not going to do that because things will become much more confusing. Just remember that we can add the horizontal facing or the access to state properties right now, and we can add a default access to the state properties if we want to. Then it has lit properties. If it has the lit properties, it adds the lit to the state properties. Now keep in mind, my own blocks has their own boolean property, and it's not being handled right now. These two, and actually these three, will be copy pasted to make the activate, because here's the thing, you may ask, why do you have the activate or active property on top of the lit? You can use the lit. Well, here's the thing, you may want to have a situation that you show a model when the block is initialized. Okay, for example, let's say that I have a machine that will show a model if it has energy in it. Okay, but at the same time, I may want to show a different model if we have the energy and we turned on the machine. Or we may not want to show the model, but we may want to take the block entity only and only when we turn on the machine. So we have to handle two different Boolean properties, if we have the energy and if we are on. And that is why I added a new Boolean on top of the lit function here. Okay, at the very least, we have to copy paste this and handle things inside our block states later for the active, but has waterloggable properties. This makes the block state waterloggable. And again, we have three overloads for that. Then we have add state property. Now this one is generic. Generic means that we have a comparable that is from Java language of any type, and then we have a property of this comparable called property with a default value. So what we are doing is that we are adding a property to our state properties as a new state property with this property and this value. Okay, the simplified version is that we want to have a Boolean. Now the Boolean property will have a name. So we say add the property with the Boolean of this name name, Boolean property of this name, and default value for the Boolean. We may want to have an enum state property. So we will add a property that uses enum property of that name with this class type and the default value. We may want to have enum state property, but other than the default value, we want to have a list of values. So we will say enum property of this name, this type, but with these values, and this is the default value. Then we have these. We have the not place facing opposite. It means that we are calling the facing opposite, but instead of default true, we are making it sure that it's false. Then we have place facing opposite with a Boolean value, and basically we are setting it as the Boolean value. Okay. Now block entity properties. Remember, this is our block properties related to a block entity, and we are setting the field using that. And the use case is here exactly block entity properties. This is the same thing. What Turtle is doing is that he is inlining the generation of the properties. You can have an extra one as the field on top or anywhere else, and then send it as a parameter here. This is the use case that we may eliminate it because we may nuke this class. Okay, then has comparator output. Make sure that we are calling our overload with true, and here we say just assign this flag with this Boolean, and then the comparator output. Now comparator output needs a tree function, get comparator output. He says this comparator output apply state word position, and the comparator output equals properties that comparator output. This is being assigned here on block properties, and you see that comparator output by default is a tree function. So he's using a block state word and position. So in here, block state word and position are the inputs, and the integer is the comparator output value. Again, you see the use case here. So by default, we are using a lambda at the top of this class, actually, I think. Yes, here. A lambda that creates a screen handler calculate comparator output for the word on this position, and the state is not being used. So now we have has block entity renderer. If we have a block entity renderer as a custom block entity renderer, then we don't want to render the block ourselves. So we say that block render type is not model. It's invisible. If we don't provide this, basically we are setting it to be the model, and I want to have an overload for this guy. This is where I'm changing it to be a Boolean is invisible, and we say if is invisible. If that's the case, please call our overload using the invisible, otherwise call it with model. And here we are calling ourselves, so we say has block entity renderer as true. As you saw, we are calling this method render type, and here we are making sure that our render type is either invisible or model. If we directly call this method, we are providing it ourselves. Okay, empty shape. Now it means that constant shape as the voxels is the voxel shapes empty, constant shape as a voxel shape. Now this one is how we can use something like this. If we have a voxel shape and we don't care about the directions, we can directly send that voxel shape here, make sure that we are using that voxel shape inside the block. Then the shape factory, if we have a voxel shape that should be rotated, that is the responsibility of shape factory. And shape factory is an interface that we will take a look at in a few minutes, or maybe another video, depending on how long this video will take. And then the can exist, we talked about it already. Use rotated shape is the example he has on the electrolyzer. So he has a multi-block, and I can say it's a multi-block because it's 2 by 2 by 2 in voxel shape. And he wants to make sure that this multi-block voxel shape will rotate based on the facing. So he says that, hey, this is the voxel shape. And then he says, if we don't have the horizontal facing, means that we forgot to call this before this. If we didn't do that, please do it for us, okay? Because we are rotating the voxel shape horizontally in our code. You will see that on calculate shape. And if we are not having set it properly, please set it properly for us. And this is a single line, so forget about the curly braces here. Then we say if the cached directional shape is empty, means that if we didn't cache the shapes right now, please run the shape calculation. We want to get all the possible rotations based on all the possible directions. Here's the cache, here's the shape. After that, at this point, we make sure that our cache is calculated. We want to get the shape factor because you're assigning something. And we say, get the state, get the word, get the position and the context. And we say this calculated shapes get for the state, at that state, get the properties facing for horizontal. This is the direction. This is the facing direction. So please use the facing direction on the shape factory. The run shape calculator goes through each direction inside the direction enumeration, and on the shape cache puts the direction with the calculation shape result. The calculation shape result is a method that makes you confused at the start, but it's not as confused as you think. So let me put some comments here for you. First of all, we are creating an array of two voxel shapes, one the shape that we have and then an empty shape. Then we want to see how many times we should rotate 90 degrees compared to north. So calculate the number of 90-degree rotations need to align the given two direction with north. This uses the horizontal quarter turn difference between the two and the north. Basically, this is how we always do the calculation for the rotations on any game engine. We have a 2, we have a target, we subtract the target from ourselves. However, this is the extra, +4, modulus 4, because we want to do it based on 90 degrees and not single degree. After that, we look to rotate the shape. We already know the number of times, so we want to rotate the shape. However, first, we iterate through each cuboid box in the voxel. Now, for each box, we have a lambda, and we calculate its rotated position and add it to a buffer. So we understand that, hey, we need to rotate it these many times. So we rotate it and then add it to a buffer. And after that, we replace our original buffer with the result, and we reset our temporary buffer to be empty. And finally, when we get out of this loop, we already got every rotation possible on this buffer. And finally, this is the final rotated shape that we return. Now, I will keep the comments on this one because this is a little bit complex for the new users of any game engine, especially this line, and what we are doing here. The way we are rotating it is this max, min x and max x, and basically using union on the cuboid. Anyway, that is the initial block properties. Now, as I said, we have few more things that we didn't cover. One, the block properties BE, and then state properties. Other than that, we already understood everything. This video is taking long, so I will stop the video. In the next video, we will come back and we will start with the block properties BE and take a look at that. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.